Hello. So today we are going to continue our series on Kotlin delegates. And so this is the first part of looking into built-in delegates that Kotlin library, standard library already provides us. And so we have 4 delegates, lazy, observable, viewable, and not null. And in this video, we are going to take a look at lazy specifically. So lazy delegate can be used when you want to wait to initialize a property until it's needed. And basically, you have a property, you don't want to initialize it right away, usually because it's expensive, and you don't want to have the initialization take a long time. And so we use this lazy delegate so that the property is initialized only on the first time it gets accessed. And so to use it, you need to provide the lambda initializer, whose purpose is to compute the value when it's first accessed, and then subsequent calls to get that property will return this remembered or this cached result. Result of the initialization, that is. And so Kotlin also provides a helper function for creating a new instance of this lazy delegate. Lazy delegate implements this interface, lazy, and T is the type of whatever property we are initializing, we are lazily initializing. And Kotlin provides a helper function for creating a new instance of the lazy delegate that uses the specified initialization function and the thread safety mode. We'll talk a little bit more about thread safety mode, but the syntax by which to use lazy is using this helper function that returns this lazy T instance. And so we pass 2 things to this lazy function: the initializer, which is the function that will create the property, and then the lazy thread safety mode, which specifies what is the how it should be handled in a multi-thread if you have multiple threads accessing it. We'll take a look at that in more details. Now, lazy can be used only for read-only properties, which makes sense because once the value is initialized, it is cached after the first call to get, and so it never gets reinitialized or get modified again. And so you can only use it for read-only properties. So you can't do some kind of var prop by lazy something. You can't do that because var means that it can be set, but with lazy, it's initialized only once and never modified again, right? And so it can only be used for read-only properties. We can actually try this. Let's try it. So let's go to the example here and change this to var. So you can see the lazy string, the type string, because that's what compute returns. It returns a string. It says has no method get value. Let's see the error. Has no method set value. So if you remember from the delegate video, to have delegate works on a var, you need a set value, but the lazy T only has a get value because it works only for read-only properties. And so it cannot serve as a delegate for a var, which is a read-write property. And so that's what this is. Now, by default, the evaluation of lazy properties is synchronized because by default, the mode that we pass here is synchronized. And this means that the value is computed only in one thread, and all other thread will see the same value that got computed. So this means that if you use mode synchronized, it guarantees that the initializer will get called at most once. It never will get called more than once. Now, one thing to know here is that if you are sure that your initialization will always happen on the same thread as the one where you use the property, then you can use lazy thread safety mode none. This basically says that you don't need to do any synchronization. And this is usually the case in Android, where we do the initialization and we use the property in the same main thread. So is it in the main thread? So which only in the main thread, which means that we don't need this synchronization feature, which has an overhead, of course, of doing it. And so if you are using a property that is lazily initialized with this lazy delegate, but you know that the initialization, both the initialization and the usage of the property will happen on one thread, surely probably the main thread in Android, then just pass as a mode none to optimize on the overhead of synchronized here, of synchronization that is done with synchronized. And so don't pass the default if you are sure it's on the same main thread. Okay, so now let's see an example here. So I have this compute function that just prints something to pretend that it's doing an expensive compute operation. Suppose this is maybe initializing a database, initializing a realm instance, for example, in Android, and just returns here a string. Now the syntax is, since it's a delegate, it's by lazy, and this lazy here function returns a lazy instance here. And why does this work? This works because if we take a look, let's see if we can find basically this works because lazy t has an extension function get value on it. That's why it works. Now this is the initializer function that we are passing. So if we can just change this to actually a function just to see this. And so if we look at the parameters, you can see we are passing the initializer. Let's actually take a look. So we can pass only the initializer, and that's what we are calling here. What that would mean is that this synchronized lazy implementation will get called. And this is the version that synchronizes on a lock to make sure the installation happens only in one thread. So if you want to change that, then you can pass mode and say lazy thread none. So this will allow us to, let's move this back to the trail lambda here. And so this means that no synchronization will happen, right? If we take a look at what will happen here, so when we pass a mode, it does one to switch, and if we use none here, it goes to unsafe lazy implementation, which doesn't do any synchronization. So you can see here, no synchronization is happening. Just to go back a little bit to why this by lazy here is possible. Why do we do by lazy here? Lazy returns an instance of lazy t, right? This interface, and this interface is just an interface, right? It doesn't have the get value function that is required for a delegate. But this works because if you see here in another lazy KT class, what we are doing is that we are creating this operator function as an extension on lazy t, and the function here that we are creating is get value with the signature that is required for a read-only property delegate. And so this is why it's working with the by syntax. And what all it's doing is returning a value, right? The main thing is done in the initialization there. Okay, so that means that, so this is a property delegate because it has the get value function. Okay, let's go back to what we had before. And so now, just to make sure and to really see that compute here, which is the initializer function, is called only once, I have this main function that just prints this test 3 times, which means it called the property, which means get will be called. And so since the premise of this lazy delegate is that the initializer function will get called only once, and subsequent calls we will get the cached value, that means that this print should be printed only once, and subsequent calls should just return test, right? So let's see if that's the case. First we can this run and run this. Okay, so it seems like we have, okay, so now it's running. So you can see the println is called only once. This here So that means that compute is called only once, and then we get the first test from this one, and then the subsequent call just call the cache value and do not call the initializer again, right? Okay, so now let's walk through the implementation in Kotlin standard library a little bit more to understand it. So again, let's go back. So this is the helper function that can be passed just the initializer. There is another variant where you can pass the mode that we saw. And there is another variant where you can explicitly pass the lock, okay? And this here just creates an instance of lazy T, the interface here, that uses, which is the delegate, that uses the specified initializer here, and if you don't pass the mode, it uses the synchronized mode. One thing to note is that this instance here, with the mode synchronized, it uses itself, like the instance of lazy itself, to synchronize on, and so just keep that in mind so you do not synchronize on the returned instance, because that may cause a deadlock. But yeah, by default it uses the synchronized version, and then if we pass the mode, it switches either. We have three possibilities: synchronized, publication, and none. What synchronized does is it uses a lock to ensure that only a single thread can initialize the lazy instance. So what we are guaranteeing here with this mode is that the initializer will get called only by one thread, and the other threads will use the same value. The other mode is publication. What this would mean is that the initializer function can be called like several times, but when it gets accessed, we will only return the first returned value. The first one that finished without one will be used. With none, no lock are used to synchronize an access to the lazy instance. And if it's accessed from multiple threads, then there is undefined behavior. That's why we should use this one only if we know that the property will be initialized and used only in the same thread. So these are the three modes possible. And so each of them has a specific class that does the implementation for it. The easier one to understand is the one that doesn't do any synchronization. So let's take a look at it. So it gets past the initializer, right? And then it has this value here that caches the result of the initializer. And you can see here it's initialized to just an object here that doesn't have any property. This is because a lazy can return null. So we don't want to initialize this to null, then we don't know if it was initialized or not. So that's why we use the initialized values here. And for the value, to get the value, so we have the getter function here that we run here. So every time we try to get the value of the delegate, this function here will be called. This get function here would be called. Okay. And the first thing we do, we check if the value was already initialized, right? If it was not, if it was not, how do we identify? So if it's equal to an initialized value, that means it was not initialized yet. So we run the initializer and we use the returned value to get it. If it was initialized, which means it's different than this object here, then we just return the value, the cached value, right? So this is the part where we cache the value and we call the initializer only once. Now this part is important. You can see here we do assign nil to the initializer after using it. This is very important, especially in Android, because it's related to memory leak. So if, let's say, you are in an activity and then in the initializer lambda, you capture something from the scope of the activity, and if the lazy delegate never gets called, then the initializer will never get assigned to null, and so you may end up with something from the activity or whatever the container class is still being captured here. So just keep that in mind. And so now that we saw this, let's see the more complicated one a little bit, the synchronized lazy implementation. So same thing, it gets past the initializer, it can get past a lock also. If the lock is not passed, then it synchronizes on itself. And so that's why we use this here. is similar to the one we just saw, where the unsafe one, except it has one additional thing, which is this synchronized block. This synchronizes on the lock here, and if it's different than the initialized value, then that means it's cached and we already initialized it, so we just return it. Otherwise, we call the initializer, set the value, and reset the initializer to null. And so very similar, except we have this synchronized block. Okay. And let's go back. So the other one is the safe publication lazy implementation. So again, you can take a look at this, but it's just keep in mind that this one, when you have multiple threads, doesn't guarantee the order. It's only like the first one that got executed, that's the value that will be used, but it doesn't guarantee that the initializer won't be called multiple times. Okay, so now that we saw the different modes, let's go back to our examples here. And let's see one more thing that I want to show here is, so this is the lazy test, the test for the lazy delegate in the Kotlin standard library. And one thing to see here that is very useful is that, so to test this, they have, so this assignment here, what it will do, it will just assign an instance of the delegate itself to this value here. And so you can see here, this is the initializer function, it just increments another variable. And you can see here, before calling this delegate, the call count is 0 because the initializer has not run yet. And then if we check if the lazy delegate was initialized using this is initialized function. So if we go back to and see what is initialized function here is. So this is a function in the lazy T implementation interface. And what it does, it returns a true if a value for this lazy instance has been already initialized. So if the delegate was already, which is lazy T, if it was already initialized, it returns true. If not, it returns false. And so here, if we do is initialized, it should return false because we haven't called lazy int yet to get the value, right? But once we do get the value with lazy int that value, so let's see where that value comes from. So that comes from the lazy interface again. We can get the value. We can get the lazily initialized value of the current lazy instance, right? And so once we get the value, that means the get function will be called. And so that means this will increment. So it's now 1. And then if we check if it's initialized again, now it's initialized because we got the value, and so it asserts true. And if we try to get the value again, the call count is still 1 because the initializer function is called only once. So this is just a test to really drive home that the initializer function will get called only once.
Okay, so now let's take a look at some examples in Android specifically to better understand the usage here. So the first example that we are going to take a look at is very simple. So we have this view, right? And we are doing by lazy so that we get the find view by ID only if message view is called. And so only in onCreate, once we call this, where we try to set the text, so only on this call that this here will be called, and it will be called only once and cached. So similar to what we usually do by setting the property, marking it as nullable, and then setting the value. Arguably, this may be like an overkill because lazy is kind of expensive since it creates some extra objects. It creates a whole new class for the delegate, class instance for the delegate. So yeah, potentially it's not worth it, right? The other example that I want to look at is a bad example of what not to do. So what not to use lazy for, essentially. So let's say I have this rectangle, right? So it just has 4 floats, right? Left, top, right, and bottom. And I just create the instance by lazy, which means this will be called only if rect is used. And so it will be called only in this onCreate. I take the text view in the layout and I set the text to whatever the value of the center is. So only once this is invoked that the lazy function here will be called. But this is really a bad example here because lazy should be used only for expensive initialization. This is not expensive. This is initializing an instance with 4 floats, so it's not expensive at all. So you should not use delegate for this use case. The second example is a better example of when to use delegate. So let's say I have a database where to get the instance, that's an expensive operation. So I'm just taking Realm here as an example, but let's just say a database or some resource that initializing it has a big cost. And so that's where it makes sense to use lazy here. And so we initialize it only if Realm is used. And so let's say here in onCreate, let's say for example, it's only in some condition that we want to use it. So I add a listener here and then get a user from it and then set the text to the username, right? And so this is also only used in some conditions. So if this condition returns false, like the case here, then this instance will not be initialized. So we are in a better shape here. The other thing you may notice here is that in onDestroy, I'm calling remove or change listener here because we may add them here. This basically makes it a little bit, this is inefficient because if some condition is false, right, then this will not run. So we will not access Realm, so we will not add any listeners, and so there is no need to remove them. So how can we avoid this? Let's see an example for that. So that's where we can use lazy delegate. This function returns a lazy instance, right? And this interface here has this function that can tell you if a lazy value was initialized or not. And so what we can do here is instead capture a reference to the lazy delegate. So we say equal to lazy instead of saying by lazy that we said here. So we capture the lazy delegate itself, we assign it to a variable, and then we can, in some condition, we can get the value, and this here just returns the lazily initialized value of the lazy instance. And so this is equivalent to getting the value this way, right? This realm here is the same as the one we obtained with that value. So we add the listener, and then we get realm, and then get the user, and then assign the user. So similar to what we had before. Now though, instead of doing what we did here, where we just accessed it here, so even though if it's not used, we still incur the cost of initializing it. Now instead, we can check if it was initialized, and only if it's initialized, we removed it. So if condition is false, then realm delegate will not be initialized at all. And so we save that cost there. If you don't like every time doing realm delegate that value, you can also use something like this, similar to what we had before in the example, except here we use that it's by this realm delegate here that we assigned. And now we can just use that like this. And that's pretty much it. And similar thing, we can use it here every time we are using realm delegate value, right? Yeah, so I think that's pretty much it. That's pretty much what I wanted to cover for lazy delegates. Thanks for watching, and see you on the next one. Bye.